Hi everyone, Professor Bob Young back at you here. In this instructional video, we are going to discuss graphing tangent and cotangent along with their variations. So here we go. All right, now before we graph tangent, I wanted to do an intuitive look at this creature here. Now remember the identity for tangent over here, if you think about it, is sine x divided by cosine x. So I took some nice angles here on the unit circle, and I wanted to go ahead and just test your unit circle abilities here. So let's look at a few of these. The sine of pi over 2 is 1. The cosine of pi over 2 is 0. The tangent would be 1 over 0 or undefined. Remember, you cannot divide by 0 in mathematics, forbidden. What is the sine and cosine of pi over 4? Well, that's the 45-degree angle there. So we're going to get the x and y values are the same because the angles there are both 45 degrees. So the sides opposite those are the same. We looked at those in other videos. Any number divided by itself, that's a nice tangent value, pi over 4. And we will find when we do cotangent, it will be nice as well. 0, the sine of 0 is 0. The cosine of 0 is 1. We get 0 over 1 for the tangent, or 0. Negative pi over 4 here. Now we're going the opposite direction. The y value will change sign, and the x value will stay the same. What happens to the tangent here? Well, anything divided by its opposite is negative 1. And at negative pi over 2, the sign, if you go in the negative direction, if you remember on the unit circle, would be negative 1. Cosine 0, undefined here. So notice at pi over 2 and negative pi over 2, the tangent is undefined, and that's going to play big time in our graphing. All right, so next up, what we want to look at is on this graph, y equals tangent x. I went ahead and started at 0, pi over 6, pi over 4. I took a lot of these first quadrant angles and even threw some other ones in here, like 75 degrees, 85 degrees, 89 degrees, right up until we hit pi over 2, which is really approximately 1.57, but 1.57 is just barely below it here. Look at these values here. When x is 0, y is 0, all right? When we're at pi over 6, we're at 0.6 on the graph. Pi over 4, here's our 1 right there, the nice one. Pi over 3, it kind of keeps going up to about 1.7 here. But notice as we get closer and closer to pi over 2, and we can even go out farther and farther, the tangent is heading toward infinity. It's shooting off the charts here. And if you were to take the negative side of this, it would do the same going this direction, noticing it's undefined at pi over 2, thus drawing the vertical asymptote at negative pi over 2 and pi over 2. So the period of a tangent graph is going to be pi long, okay? Notice the tangent function is an odd function. When you replace x with negative x, it changes sign and it has origin symmetry. And of course, it is undefined at pi over 2. So characteristics of these tangent graphs, so remember, this is just one full period here, pi. It keeps going endlessly both directions here. The period, as we already mentioned, is pi. The domain, all real numbers except odd multiples of pi over 2, and some textbooks will have pi over 2n there with integer values. Notice the range, the y values, all real numbers. All right, so we already mentioned that the vertical asymptotes were odd multiples of pi over 2 here. And notice this thing keeps going from negative infinity to infinity. We just first looked at one period of the tangent, but remember, this thing goes both directions in those pi intervals here with asymptotes with odd multiples of pi over 2. And notice on these asymptotes, the intercept occurs halfway between the asymptotes. So that's something to note. And these nice x values occur halfway between the asymptote and the intercept. So I want to stop and look at that a second as we continue. Now, whenever you graph tangents, the variation ones here, now notice here's the general form we talked about with sine and cosine as well. Y equals A tangent BX minus C here. Now, what it's nice to do, and it'll help you graph every tangent graph, is to go ahead and take whatever is after the tangent here. Now, notice I didn't put the D number again. You can always up or down the D number like we did on sine and cosine. So let's forget about D right now. And we're going to take that and set it between negative pi over 2 and pi over 2. So this will always get you your asymptote. So when you solve this for x, whatever it is, and we're going to do a few of these, you'll get your asymptotes. Now the x-intercept is going to be halfway between those consecutive asymptotes. So I want to give you a little formula on how to get it. All right, so what I like to tell students is to take the asymptote, I'll say A1, plus add the two asymptotes together and divide by 2, because really that's the midpoint formula if you remember college algebra or your pre-calc algebra class. So add up the asymptotes, divide by 2, and that will get you your x-intercept. Now to find those nice values for tangent and cotangent, the ones that's 1/4 of the way and 3/4 of the way between the consecutive asymptotes, I'm going to use the midpoint formula again. So to find, I'm going to put nice tangent values here. And this is going to work for cotangent as well, by the way, once we look at its characteristics and so forth. I'm going to take the intercept, okay, where it crosses the x-axis, plus one of the asymptotes, and it doesn't matter which one you take, and divide by 2. And you can do this with both asymptotes if you want to get the really nice tangent values, and we'll see this as we progress as well. All right, so when graphing the tangent in review here, to get the asymptotes, take whatever the bx minus c part is, equals negative pi over 2 equals pi over 2, solve. Your intercept's halfway between there, and your nice tangent values are halfway between the intercept and asymptote in both cases. All right, so let's go ahead and graph one of these real quick. We're going to graph y equals 3 tangent 2x for this interval, except we might even go outside this interval and show off. All right, so notice we've got the a number is 3. Now the a number here, what happens with the, I guess we call these in sines and cosines, the amplitude, it's just going to stretch the tangent graph up or down. The larger this number goes, it's going to make it skinnier and skinnier. And if it's a fraction, it's going to make it a little bit fatter, which I like to say, rather than stretching and shrinking and so forth, I call it skinnier or fatter. So the b and c number now, the bx minus c, b is 2, c is 0, find your asymptote. So that's the first thing to do when graphing tangent. So we're going to take the bx minus c, we're going to set it between negative pi over 2 and pi over 2, where those tangent values are undefined. So the 2x we're going to take in there, stick it in here, divide everything by 2, and voila, there are your asymptotes of negative pi over 4 to pi over 4. So an interval containing one period is going to be between negative pi over 4 and pi over 4. And then we will show you how to graph the rest. All right, so graphing this creature, we're going to go ahead and put the asymptotes here at pi over 4. And I'll do my usual on the asymptotes. So this is where this graph would be undefined here, and at negative pi over 4. Now let me show you my little formula here. Now this is an easy one. Y'all can see that what's halfway between these two, the intercept is going to be 0. It's always halfway between the two asymptotes. So here's Young's formula, asymptote 1 plus asymptote 2 using the midpoint formula divided by 2. Now when they're not so easy, you may appreciate this a little bit more. We'll see, depending on the values, you'll get 0. So 0, 0, when x is 0, we'll have 3 times the tangent of 2 times 0, 0. The tangent of 0, 0 will get 0. All right, now the point halfway between here is going to be the nice tangent value and the one halfway between here. So here's my little midpoint formula here. If you take the intercept, which is 0, plus one of the asymptotes, I'll take this one to the right and divide it by 2, you will see you'll get nice x values here. So we'll say 0 plus pi over 4 divided by 2. Pi over 4 divided by 2 is pi over 8. So check this out. When we put pi over 8 in here in the problem, we're going to get 3 times the tangent of 2 times pi over 8 is a very friendly pi over 4. Remember, I said these are nice tangent and cotangent values, pi over 4, because you got the square root of 2 over 2 for x and the square root of 2 over 2 for y. That's 1 times 3, you get 3. And also this amplitude here just stretches this graph out. So at pi over 8, we're going to get 3 up here. And similarly, you could also say that, well, that's pi over 8. This is going to be from 0, negative pi over 8, which if you plug that in, you're going to get the tangent of negative pi over 4, which is negative 1. So you're going to get negative 3 here. And then you can connect your dots for one full period. Now, again, on my writing tablet, this is always an adventure, especially, why did I have to pick a real skinny s? I should have picked a fatter s here and made that 3 a fraction, but that's okay. There's your tangent, your one period. Now, of course, tangent, you want to keep going here. So since these are a period of negative pi over 4 to pi over 4 is pi over 2 apart, you could keep adding pi over 2 to the left and subtracting pi over 2 to the right here. So another pi over 2, if you're at pi over 4, would be over here at 3 pi over 4. So you could keep doing this and make as many curves as you wanted to. At negative pi over 2, you'd be at negative 3 pi over 4. Okay, so once you get these asymptotes here, you can cheat a little bit and say, well, these are the asymptotes. That's the point halfway. This point up here will be halfway between here and match that. This point down here will be halfway between and match that. And then you can keep making as many tangent curves as you wish. And they should all kind of look the same here, as neat as you can get them, as nice as you can get them all the way down, and so forth. I'll do one more here. And if I can do it on my writing tablet on a regular piece of paper, y'all with pencils and stuff and erasers could make this really look much better, I'm sure. I'm trying. Oh, that one kind of deviated off. Stop it, Young. All right, but you get the gist, I hope. So there is our tangent example, and now you know what it's going to be on to next. Hold your horses. Yes, it's time to look at cotangent. Now remember, cotangent and tangent are reciprocal identities, but the cotangent now, by definition, is cosine x over sine x. So when I play this intuitive game, you're going to see some different things happening here. All right, the cosine of 0 is 1, the sine of 0 is 0, the tangent is going to be undefined. And notice I chose some different angles. I didn't pick pi over 2 to negative pi over 2. I chose 0 to pi. All right, at pi over 4, where are we at? Well, been down this road before. Square root of 2 over 2, square root of 2 over 2. Anything divided by itself is 1. At pi over 2, the cosine is 0. The sine is 1. We get 0 over 1 is 0. At 3 pi over 4, what happens here? Well, x changes sign in the second quadrant. I hope you're getting that circle down. Y stays the same. We go to negative 1. So again, notice we have nice cotangent and tangent values in these intervals of pi over 4 and negative pi over 4 if we want to go that direction. And at the cosine of pi down here, and we put pi in for x, we're at negative 1. Sine 0, we're in trouble here again. So notice the cotangent's undefined values are not at negative pi over 2 to pi over 2, because that's when the cosine was on the bottom. When the sine's on the bottom, it's 0 and pi. And that is going to really translate into our graphs as well. All right, so notice how most cotangent graphs appear, where our tangents kind of look like y equals x cubed in college algebra. It's reciprocal, goes the opposite direction. It really does kind of look like a slanty S cotangent. All right, the period is still pi. Pi, you have asymptotes at 0, pi, 2 pi, and so forth. Domain, all real numbers except multiples of pi, or some text will say pi n with integer values for n. Range, all real numbers. All right, the vertical asymptotes here we mentioned already. Now again, just like tangent, watch how similar these are now. The x-intercept occurs right between the asymptotes. The formula is still going to hold a1 plus a2 divided by 2, okay? Odd function here with the origin symmetry, okay? It's going to behave about the origin here. This goes to here, this goes to here. This does reflect about the origin, and those quarter of the way and 3/4 of the way points are going to give you your nice cotangent values. Okay, continuing here, we have the general formula y equals a cotan bx minus c here. So very similar to tangent, except we're taking that bx minus c, and instead of negative pi over 2 to pi over 2, cotangent's undefined at 0 and pi. That's going to give you your nice asymptotes. Once you get those, the intercept's halfway between. The nice x values are between those, and we'll do some. Here's the basic graph here. So take whatever comes after tangent, that bx minus c, set it equal to 0 and pi, solve. The x-intercept's halfway, the nice values halfway between the intercept and the asymptote. Just remember, the cotangent tends to look like this versus its reciprocal cousin, tangent. All right, so I'll try to throw some different numbers at you here. I'm going to say that if you have y equals 1/2 the cotangent of pi over 2x, well, the a number is 1/2, so that should make the cotangent a little bit wider than the skinnier ones I had when we had a 3 in the other example. The b number is pi over 2, and the c number is still 0 in this example. And we want to get 2 consecutive asymptotes. How do we do it? We take that bx minus c, whatever's here, set it between 0 and pi. Here we're going to do it. To solve for x in the middle, we're going to have to multiply everything by pi over 2, which will give us 0 times pi over 2 is 0. Pi over 2 will chop out, giving us x in the middle, pi over 2 here. So we get some numbers on this one. We've got consecutive asymptotes, 0 and 2. So an interval containing 1 period is going to be between 0 and 2, and the consecutive asymptotes are going to occur between there, so let's get to the graph. All right, so we're going to go ahead here and change these x values down here, not the pi over 2, because the pi's canceled out. So we're just going to put 1, 2, 3, 4. So you may have to adjust your graph paper depending on what you're throwing here, -2, -3, -4. So we said we had asymptotes at when x equals 0, that the cotangent was undefined. So I tried to get some red in here, and 2. So we'll go da, 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 da. Now this one's super nice because I bet y'all see, gee, I wonder what the intercept is between those, young. Yes, it would be right here in the middle, 1. So if we put 1 in here, I will bet you we're going to get 0 here, because the cotangent of 0 here, or I'm sorry, the cotangent of pi over 2 here is going to get you 0, and then times 1/2 you'll get 0. Now what happens if I go left here? All right, now I can show you my formula here. We can say the first asymptote plus that intercept divided by 2 will give me a nice value for x. So I'm going to put in the asymptote of 0, the intercept of 1 divided by 2. So I wonder what happens if we plug 1/2 in here, young. Will I get a nice cotangent value? We will see. So we will come up here to the top and say 1/2 times the cotangent of pi over 2 times 1/2 would be, oh, it's that number, pi over 4, not the cosine, the cotangent there, sorry. And the cotangent of pi over 4 is 1 times 1/2. You're going to get 1/2 here. So 1/2 will be there. And anyone want to bet what happens if you put in 1 1/2 or 3 halves here? You're going to get the cotangent of 3 pi over 4, which is -1. When you put in 1½ or 3/2 here, here's what you're going to get, and you're going to be at -1/2. So you can see this one's going to be kind of a wider S. So if we hug our asymptotes, which we should always do, and we go through those nice, oh, I missed it on that slidey writing tablet, the nice X values, this cotangent graph is looking like this. And if you want a few more, you can go over here, make a few more asymptotes. This went from 0 to 2, so these are going to be 2 apart. And there is your intercept, and then you can still match up your values to the left and right of that and do as many periods as you wish. All right, so I want to do one last example now that has the A, B, and C numbers in it. So this is a tangent graph, so we're going to take that bx minus c part here, the pi over 4x plus pi over 2, and set it between, since it's tangent, pi over 2 and negative pi over 2. Now, if this was cotangent, it would be 0 and pi here, so just the differences. Solve for x here, so we're going to subtract pi over 2 from all parts here. So this would leave us with a minus pi is less than pi over 4x is less than 0. And to solve this for x, we would multiply all parts by 4 over pi to get x by itself in the middle. So what we would end up with, the pi's would chop out here, cancel out, and you would be left with 4 is less than x is less than 0, and that would be your asymptotes here. So we can go ahead and change our x values here. 1, 2, just wipe these out here. 3, 4, -1, -2, -3, -4. So we know that from -4, we can go ahead and go dot, 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 dot. Here's an asymptote. Okay, and at 0, here's an asymptote. So all of these work the same way, no matter how complex they make the A, B, and C numbers. All right, what's halfway between there? I think everyone sees this one. Now, of course, you could say -4 plus 0 divided by 2, and you would get -2 there for the intercept. So that would be 1 point. Halfway between there, you could say 0 plus -2 divided by 2 would get you -1. So you're going to get your nice tangent value when x is -1 there. All right, so let's see it here. So 1 pi over 4 times -1, this would be negative pi over 4 plus pi over 2. So when you put -1 in here, folks, you're going to get 2 times the tangent of, oh, there's that nice pi over 4 weight on it, which is 1 times 2. You're going to get 2 at -1. And then the other nice value would be halfway between here at -3, but I think y'all will see what happens here. This one's going to end up down here on -2. So you've got some kind of symmetry going here. Connect the dots for the S. And I'll try to make a good tangent S here. Hug those asymptotes. We can make this a little better in here. Oh, I hate this writing tablet. Sometimes it's slippery, but if you really want to impress your instructor, you can kind of color that in and make it look real tangent-esque. I don't know if that's really a word, tangent-esque. But we're going to slip it in there just for good measure. All right, so, and then if you want to, since these are 4, you can make another asymptote every period of 4 on this one. And then you can still go ahead and connect those same dots. You could match up halfway, and then you can match up here at 2, and this would be at -2, and keep going forever and ever. So I wanted to throw one more example in there before I signed off on this one. And there you go. Start working on those tangents and cotangents yourself. See how you do. Bye.